Greetings everybody and welcome back to another video. Today we've got something special for you guys here. I'm going to be showcasing a complex function grapher and animator that I made here in Desmos. So I've been working on this since like sometime last year and just been adding bits and pieces to it here and there, and it's at the point now where I'm quite happy with its functionalities and features and whatnot. So I'm going to be releasing it into the wild, so link to this project will be in the description of this video, and yeah, you guys can play around with it. And if I do make any updates or substantial changes to it, then I'll probably change the link in the description as well. But yeah, let's just jump straight into the video. What on earth is this whole project here about? So essentially this is a function grapher for complex functions to be precise, where you can put in any function you want here and you can kind of animate the mapping, and you can also animates this domain here that's moving around. So what you're seeing is a Mobius transformation, and this lightly colored input grid over here. The lightly colored grid, that's the input grid, and then you have this slightly more boldly colored grid over here, and that's the output grid. Right, so as this input grid is moving around using the animation that I've put in, you can see the outputs changing. So it's a pretty cool way to visualize the complex function. So that's only one of the ways you can use this to animate things. Let's actually go to the other type of animation you can do. So I think I have to do that or something, and then let's change this animation mode. Let's speed things up a little bit as well. Normal speed. So what we have now, this is a different type of animation. I'll go into all the details as to how to use it later, but if we play this animation, you can kind of see that you have the input grid over here. It kind of warps into the output grid, which is pretty cool. So you can use this to kind of visualize what your complex mapping is doing. So this is very similar to those 3 blue 1 brown animations that you see, and which is roughly what I tried to base this off of. So you can change this to a square transformation. I believe it's SQ. Yeah, there we go. And you can kind of see this input grid over here, what happens under the square transformation. So as you can see, plus or minus I, which is on the vertical axis over here, it gets maps to -1. Don't know if you guys can see that clearly because the background is black, but yeah, you can visualize complex mappings quite nicely. So how on earth does this whole thing work? Well, if you click onto the projects link in the description, you can read through all this stuff. Don't even know if I've finished writing it yet, but yeah, I'll probably finish it, hopefully, before posting the link. And yeah, essentially this is where you put in your function, your complex function. Now, as you may notice, I can't just type in something like z squared over here because Desmos doesn't know how to work with complex functions. So what we have to do is kind of define predefined functions, and that's going to be found in this function library here. So this is adapted from another complex grapher that I found somewhere. I think this guy made a YouTube video on his as well, so you can check out his projects there if you want. But basically you got all these functions here that you can use, and the way this works really is that we're using z as our complex variable here. Now what z represents is just a point in this Cartesian plane. Well, complex plane, but Desmos, it's a Cartesian plane. So z kind of has 2 components, an x component and a y component. And what all these functions here are doing, so if we go down to the function library, let's take a look at a fairly simple one. Let's say the square transformation over here. What we have to do is we have to compute the real part of the function and the imaginary part of the function based on the real and imaginary parts of the inputs. So if you want, this is kind of like the u of xy and the v of xy if you've studied complex functions before. And we have to define the complex function using the real imaginary parts because Desmos doesn't know how to work with complex numbers. Now because these z's over here, these are coordinates, so an x and y pair, what you can do is, let's say, put in a z, so f of z equals z, that's just the identity map, so nothing really special happens there. But what you can do is, let's say, put in 2z, so that's just a dilation by a factor of 2. And as you can see, this input grid kind of grows into the output grid over here. Now you could try to graph 2z plus 1, and you might notice that nothing appears over here. Now that's because z is a coordinate, 2 is, it's a scalar, so you can multiply into this coordinate and it's a coordinate. Now unfortunately, 1 isn't a coordinate here. 1, that's just a number, you can't add it with this coordinates pair. So what you have to do, I've kind of defined this somewhere in here. If you want to have the 2z plus 1, you have to do 2z plus 1r. So what this r here, that's just a unit, so one real number, the multiplicative identity of the complex plane. So this would be representing the map 2z plus 1 pretty much. And if you want, you can remove that 2 there, and you can kind of see this plane, this input grid is being translated to the right. Okay, and if you want to add an imaginary number, well, how do you represent imaginary numbers? Well, it's going to be I can predefine this somewhere else. So I, or you can even write it like 0, 1 as well. So this is how you represent the number I in, well, as a coordinate, but I've predefined that as I, so you could add something like 3i if you wanted. And now it's going to be shifting up. Okay, so what happens if you want to start multiplying things down? Let's say you want to have a z and then you want to multiply by z plus 1, let's say. Well, remember, you can't just do z plus 1, you have to do z plus 1r. Well, this doesn't work here because Desmos has no clue how to do complex multiplication. It doesn't know how to do addition, or complex addition, because you're just adding the coordinates together components-wise, but multiplication has no clue how to do that. So I have defined a times function down here. So you put in 2 coordinates, or 2 complex numbers, and the output, well, that's just what you get when you multiply 2 complex numbers using the real imaginary parts. So what you have to do here is you have to use the times function, so it's t and then you do underscore IMES, so that's times there, and then you put z, comma, and then the second argument. So those are the 2 things that are being multiplied there. So now you can see we have a quadratic map going on. So you can explore all the other functions you can use down in this function library here. You can even add more if you want to, if there's any that I have forgotten to put in. Let's take the exponential function, for instance. So you can do exp for exponential of z, and as you can see, we have this exponential map. So that's how you input functions into this thing, and of course you can do composite functions as well. So you can do exponential, let's do a Gaussian function, so negative, and then we'll do a, we want to square, so sq of z. So this would be what the Gaussian or the bell curve looks like in the complex plane if you want to. Alright, so that's how you input functions. You can compose them and whatsoever. Now let's take a look at this input grid over here, because you kind of want to see what your function looks like at different points in the complex plane. So if you look very closely, actually what I'll do, there's another little folder here called visual settings, and down over here you can change the background color. Here's the thumbnail grade that I use in my thumbnails, but at the moment it's on black, so let's get rid of the black over here, so now you can hopefully see things a bit more clearly. So if you take a look at this input grid, let's pause this animation. So all the animations are controlled by this animate slider over here. Let's pause that, let's set it to 1, so that's the proper image of the function. If you take a look at the input grid, you can see this little center point over here, and you can kind of drag that around. So let's choose a slightly less exotic function. Let's just go for a nice square function. So you can drag the center around, and you can see the output grid changing as well. Now you can also resize this. So if you look closely, there's these corners over here, and you can resize this guy however you want. So you can resize it to your liking, but in order to move things around, you move it using this center point over here. So you can explore what the function looks like at different points in the complex plane, which is pretty cool. And as I said before, there's this animate slider, so you can kind of morph the input plane or the input grid into the output grid, which is pretty cool. Now also inside of this visual settings, you got the grid density. And this basically controls how many grid lines there are per unit interval or unit square, however you want to count it. So at the moment there's a grid density of 2, which means if you take a look at every 1 unit, so let's say from 0 to 1, there's going to be 2 grid lines, right? And you can increase this, and there's going to be more grid lines, but of course more grid lines means more computation, which means more laggy. So usually I don't go that high, especially if I'm recording. I'll just put something like 2 is a good number, I guess. Right, so you can change the grid line density, and you can play around with these colors as well. So this is the gray that I use in my thumbnails, and then we have a lighter black and a black, and you can change the colors depending on, I forgot how you change the colors actually. I think you go here and you do something. I don't know if you can have custom colors, but you can probably play around with that if you want to. That's the visuals there. Now if you want a bit more of a finer control over the input grid, you can go into this folder here, and you can precisely change what's the where the midpoint is. Alright, so let's put the midpoints back to, let's just put it to 0, 0. And then you have these lengths over here. I'll probably name these a bit more appropriate names later, but I think X length 1 is to the right, so let's change that to 1. X length 2 is the left side, and then Y length 1 is the upper side, and then Y length 2, that's the lower side. So now we got to this nice 2x2 square here. Right, so what have we covered so far? We've got an input grid, function library. So next up we have this smooth selection. So what on earth is smooth selection over here? If we change this to a 0 and we try to animate the input grid going to the output grid, you can see that it's not very smooth, especially at the start and at the end of the animation. Basically how this animation works is that we're using I don't know what's called properly, a linear homotopy or something like that. So basically points from the inputs, they get mapped in a straight line to where they would be in the output, in a linear fashion. So because of that, at the very start and at the very end, you get that weird little, it's not very smooth there. So if you change the smooth selection to, let's say 1, it's a bit more smooth at the ends there, as you can see. And you can change that to a 2 as well, and it's slightly more smooth, and you can go all the way up to 4, and that's as far as I go there. And basically what's happening behind the scenes, if you go to these smooth step functions, is smooth step functions. You can read this Wikipedia article on them. It's basically just a bunch of polynomial functions with nice behavior at the endpoints. But yeah, those are the smooth step functions. That pretty much covers everything for this animation part over here, changing the input grid to the output grid. So now let's take a look at something a bit more complicated, I guess. This is animation from the input grid to the output grid. You can also animate the domain, so exactly how I had it at the start of the video, where the domain was moving around by itself, and then you had the output changing as the domain moved around. So to do that, you want to go to this domain animation here, and you want to turn domain animates to 1, so you have 0 for off and then 1 for on. So now what this does is it fixes the output grid to the actual map of the function, and you still have the inputs grid over here. And then you have this function called a path of center. So path of center, it's going to be some kinds of parametric function in 2 dimensions, of course, which controls where the center of this input grid should go. Right, so at the moment, I have this set to animation selection is number 7. So if you go down to animation presets over here, the 7th animation preset is animating a square. So I've kind of figured out how to make the domain follow a square shape over here. Alright, so you can animate now, and this is going to hopefully, whoops, that's the wrong one. You got to go to the animator, and then now you animate this guy. So as you can see, this moves around in a square, kind of. And if we're going in a square because we're just repeating the same cycle over and over again, we might as well use this animation mode so it just doesn't go backwards again once it hits the ends. And you can come up with your own path for this domain grid here to follow using these animations here, or you can type it right into this path of center part here. If you have it to animation presets, then you can have all these presets going on over here, and you can kind of change between them, which is nice. But let's just keep it on animation presets. We'll go to the first animation that I have loaded on. So this is 4t, 0. And by the way, the parameter range is from 0 to 1 here. So if you take a look at 4t, you'd expect that the point or the center points should move from 0 all the way up to 4. Like so. And of course you can put on the smooth selection as well. So you can put on smooth step 2 if you want it to be a bit smoother at the end. But yeah, let's come up with our own animation now. So let's go to animation number 2, and let's try to make this square go in a little bit of a circle. So you can take a look at, let's do cosine. Now because we want a full circle to occur on the interval 0 to 1 for our parameter, and we have to multiply the inside by 2 pi, so we have cosine of 2 pi t, then sine of 2 pi t. So when t goes from 0 to 1, then we make a full revolution around. Now this is still on the first animation, so let's change the animation selection to number 2, and as you can see, we have this square going around. Now sometimes it's a bit funny because, yeah, as you can see, the endpoints or the edges over here, they're kind of flickering. So usually what I do, if we go down to the input grid over here, I just increase the lengths of each side by like 0.001, and that does the job. Right, so you can make this go around a circle, and you can see how the output changes as well, and you can come up with your own path to animate and whatsoever. And of course, if you want to go back to the animation type where you change from the input grid to the output grid, all you got to do is you just gotta turn animates domain off, and now it's back to animating input grid turning into output grid. So that's all covered. Don't think I missed anything. So next we have just some random things. So for example, we can turn on this pointer here. So basically you have this green dots over here, which you can kind of move around in your input grid, and then that yellow cross there, that's going to be the corresponding points in the output grid. So you can take a look at specific points, and you can take a look at where they map in the output space. So that's the pointer there. You can turn that off if you don't want to see that. And by the way, you can see the actual complex numbers as well, which is nice. Might be a bit tricky because of the black background, but if you go to visual settings and you turn that black off, then you should be able to see it quite nicely. Okay, so that's pointer, and you also got these are just graphics. So if you disable that folder, you don't see anything. So you better keep that guy on. And data, that's just random stuff on how things work, and you can look through this if you're interested to see how things work and whatnot. What else do we have? We have branch cuts as well. That's something I'm still kind of working on. I mean, it should work for most of the functions with branch cuts. For example, you can take a look at the log transformation, so ln of z. So this is what the transformation looks like. And what you can do is you can change the branch of the logarithm. So at the moment, the branch of the logarithm is from negative pi to positive pi. So you can kind of see it's going down to 3 point something over here, or negative 3 point something. By the way, if you zoom in too much, then it kind of turns white. But yeah, negative pi to positive pi, that's the current branch we're on. But if you go to the branch cuts over here, you can actually change the branch. So the branch starts at whatever this number is, then it just adds 2 pi to it. So if we want the branch of the logarithm to be 0 to pi, we'll just change this to 0. And now you can see the outputs, or the imaginary part of the logarithm is from 0 to pi, because the imaginary part is precisely the arguments of the specific number that you provide the logarithm. Right, so that's for the logs. You can also do square root functions. So you can type in sqrt of z, and yeah, you got this nice square roots function going on over here, right? And at the moment, what's the arguments? It's from 0 to pi, and I believe if you can change this around probably. And yeah, you can kind of see it messes with this output grid a little bit. And you can show the branch cuts if you want as well. So let's show the branch cuts. And there's the branch cuts right over there. So you can move this branch cuts around here. And if you take a close look when the animation starts, so right about now, you can see that right at the branch cut, that's when things kind of cut and then it moves into place. Right, so that's the branch cut. You can see what the branch cuts is doing. It's not a complete feature yet, because if you do things like square root of z and then you add a to r, for instance, does that even work? I don't even know. I think maybe we have to move this grid now for it to kind of split across here. It's a bit funny if you show the branch cut that way, because the branch point isn't really at 0. Now the branch point is at well, wherever. What is it? -2. So maybe I'll fix that or change that in another update if I can be bothered working on it. That's the branch cut. And then what's the final one? I guess Mobius transformation, which was the one I was showing you before. So to use the Mobius transformation, you just got to type in Mobius over here and then z. And this is some Mobius transformation. Now, how do you decide which Mobius transformation to use? Well, if you just activate this folder here, you can see all the points. So you have the A and the B. So the Mobius transformation takes the form AZ plus B over CZ plus D. So you can kind of drag these points here around and you can see how the Mobius function changes, I guess. You have this green circle over here. That's the point that gets mapped to 0. And you also got this cross over here, this orange cross. That's the point that gets mapped to infinity. So you can kind of play around with this, because if you put your grid slightly onto that pole there, then everything kind of gets, it gets inverted. And if you put a point on 0, then I don't think anything special happens. On that point over there should kind of start moving towards 0, as we expect. So somewhere around there. There we go. So that's Mobius over there, and of course if you click into this folder, you can play with the specific complex numbers here. That's to find the Mobius transformation. So that is about it for this complex grapher and animator. I've used this in like 1 or 2 of my videos, might use it in more. But yeah, as I said in the start of the video, link to this project is in the description, so you guys can have a play around with it if you want to. And yeah, let me know how it goes. And if you have any features or stuff you would like to see me implement into this thing, then let me know in the comments below. And yeah, that's going to be all for this video. Hopefully you guys enjoyed, and I'll see everyone in the next video. Bye bye.